turbochargers are commonly used in passenger cars to obtain greater power output from a given engine size. The compact nature of a turbocharger means it is often a more space-efficient solution for increasing power output than increasing engine displacement. As an example, the turbo Porsche 944's acceleration performance was very similar to that of the larger engine naturally aspirated Porsche 928. Although turbocharging is less responsive than supercharging, turbocharging is generally considered more efficient than supercharging. New techniques such as twin-turbo/biturbo, whether parallel or sequential, setups and twin-scroll turbocharger, in combination with technologies such as variable valve timing and direct fuel injection, have cut down on turbo lag. Multiple turbochargers. Parallel. Some engines, such as V-type engines, utilize two identically sized, each fed by a separate set of exhaust streams from the engine. Having two smaller turbos produce the same aggregate amount of boost as a larger single turbo allows them to reach their optimal RPM more quickly, thus improving boost delivery. Such an arrangement of turbos is typically referred to as a parallel twin-turbo system. The first production automobile with parallel twin turbochargers was the Maserati biturbo of the early 1980s. Sequential. Another twin-turbo arrangement is sequential, where one turbo is active across the entire rev range of the engine and the other activates at higher RPM. Below this RPM, both exhaust and air inlet of the secondary turbo are closed. Being individually smaller, they have reduced lag, and having the second turbo operating at a higher RPM range allows it to get to full rotational speed before it is required. Such combinations are referred to as a sequential twin-turbo. Cars using sequential twin-turbos include the Porsche 959, Mazda RX-7, Toyota Supra and Subaru Legacy. Sequential twin-turbos are usually much more complicated than a single or parallel twin-turbo systems because they require three sets of intake and wastegate pipes and valves to control the direction of the exhaust gases. Triple-turbo. BMW's diesel N57S is the only tri-turbo engine currently available. In Formula One, in the so-called turbo era of 1977 until 1988, Renault, Honda, BMW, and Ferrari produced engines with a capacity of 1,500 cc, 92 cubic inches, able to generate 1,000 to 1,500 horsepower, 750 to 1,120 kilowatts. Renault was the first manufacturer to apply turbo technology in F1 turbocharged engines, dominated and ended the Cosworth DFV era in the mid-1980s. In 1987, FIA decided to limit the maximum boost before the technology was banned for 1989. Rule changes for the 2014 season marked a return of turbocharged engines to the sport, from the previous normally aspirated 2.4-litre V8 engines to turbocharged 1.6-litre V6 engines.